Okay, today we are going to look at multiplying fractions and whole numbers. We've already seen some of these examples in our bell ringer last week where we talked a lot about what do you do with the whole number. When you have multiplying by a fraction, what do you have to do to that whole number? Do you remember?
Turn it to, I know. Turn it into a fraction and have the denominator 1.
Yep, turn it into a fraction by making the denominator 1. Okay, so we are starting with, make sure you're on the right page in your journal. You should be on page, is it 30? Okay, 30, which is lesson 48. So it says multiplying fractions and whole numbers. I know both of them look similar, so make sure you're looking at the one that says 48. Okay, it says, tip, when multiplying whole numbers, I'm going to make this just a little bit bigger here. When multiplying whole numbers by fractions, always make sure both products are in fraction form. Okay, so we're going to change the fractions, or we're going to change the whole numbers to fractions. So if you look over to the right, I have 5 times 1/3, and then I have 4 times 1/2. So the first thing I'm going to do is make them into fractions. I think this, okay, well, it's fine. So we're going to put a 1 underneath it, just like that. So what I'm now looking at is 5/1 times 1/3. If having it like this bothers you with my denominators off like that, then you can rewrite it so that they're directly across from each other. Okay, so this is what my problem will look like once I set it up. Now, if I'm looking at these two problems here, it's the same exact problem. I have 3/4 times 5, but it says standard multiplication method versus models, because you need to still know and understand how the models work and represent the fraction multiplication as well. So over here in the standard algorithm method, it gives me my steps, change both products to fractions, and then we're going to multiply numerator times numerator, then multiply denominator times denominator, and then simplify. So we're just going to copy down this problem, 3/4 times 5/1, because I want to make sure that that 5 whole number is written as a fraction. Then I'm going to multiply straight across. So what I'm doing is I'm really just doing 3 times 5, which is equal to 15. And then my denominators were 4 and 1, so I'm just doing 4 times 1 to get 4. But it's improper, so this is where the simplifying comes in handy. How many whole times can 4 go into 15? This is where the division helps. If you can't see it right away, just divide it out. 4 goes into 15, yep, 3 times. So 3 is my whole number. My remainder is my numerator, which is 3. And then the denominator is 4. And that's the divisor. Okay. Now, what does that look like? Basically, what this problem is saying is 3/4 5 times. So 3/4 times 5. I want to show 3/4 5 different times. So I'm going to shade 3/4 in this model. I'm going to do 3/4 in this model. That's 2 3/4. Remember, multiplication is just repeated addition. 3/4 in this model. I have to do it 2 more times because I want to have it 5 times. Okay. Now when I'm trying to figure out the product with a model like this, what you got to do once you are modeling 3/4 5 different times, you're going to count all of the shaded parts. How many shaded parts do I have? I have 15. So there are 15 shaded parts out of 4 of the original, because all of these models are broken into fourths. So 4 is my denominator, but I have 15 fourths, and I'm still going to simplify it, and it's still going to be 3 3/4, just like how I did a minute ago. Okay, I want you to go ahead and do 2/3 times 4. Just write that one out on your own, and then we'll check it real quick. So you can rewrite it so that 4/1 lines up perfectly if you'd like to, or you know to multiply the numerator times that whole number. Denominator will not change. Don't forget you can't leave a fraction improper. So you've got to do one extra step where you change that improper fraction to a mixed number by dividing. 3 goes into, I'm just showing those of you who are still a little confused on changing mixed to improper and improper to mixed. 3 goes into 8 twice. So my numerator, my numerator will be 2. My denominator will be 3. My whole number is here. So when I write my answer, I have 2 and 2/3. Again, the number at the top, my quotient, that's my whole number. My remainder is my numerator, and the divisor is the denominator. That's just refreshing that improper to mixed number, if you forgot. Okay, that's the first one. The next thing that we're doing is multiplying whole numbers by fractions. So now we're flip-flopping where the whole number is and what that looks like. Okay, so same concept, so it's going to go pretty quickly. We are going to first change a whole number to a fraction. So I'm going to rewrite it because both products need to be in fraction form. Both products must be in fraction form. So I've got to change that whole number to a fraction. So I'm going to rewrite it so that it looks like this. 5/1 times 1/4. Step 2 says multiply your numerators. So I'm going to do 5 times 1, which is 5. And then multiply my denominators, which are 1 and 4. So I'm going to do 1 times 4, which equals 4. Step 4, simplify if needed, change to mixed number if it is improper. This is improper, so I'm going to change it. 5/4 is equal to 1 and 1/4. All it does is flip the whole number first. It's the exact same process. Okay, here's what this one will look like. If I have 5 times 1/4, I'm showing 5 of something, but each one of those 5 models is representing a fourth. So I'm going to split each one of these models into 4 parts. Okay, so how many of these fourths am I going to be shading?
1.
Only 1. Okay, when you get down to the last part, I have 5 groups of 1/4. So what do you think these little circles over here on the side, what do you think these are for?
Whole?
What? Whole, where you're kind of combining all of those 1/4 pieces. And I'm going to divide each of these into fourths also. And I'm going to take each one of these pieces and fill in a fourth over here. So I have a fourth plus another fourth plus another fourth. Oops. Ah, I did it again.
It's okay.
And then another fourth. Okay, now this circle is represented by all 4 of these. Is everybody with me? Okay, I'm just consolidating. I'm taking all of these and putting it all into one. 1, 2, 3, 4 fourths. 1, 2, 3, 4 fourths. Well, what happens with this one? Just
Add it to the 1.
Yeah, just goes to the bottom over here. Okay, so this is showing 1 whole and 3 fourths. Oh, 1/4. Why did I write 3 fourths? That's weird. Sorry. So 1 and 1/4. Yeah. Okay, standard algorithm. Y'all go ahead and do that middle problem there, right at the bottom. 3 times 2/5. What will that look like if you rewrite it? 3/1 times 2/5. Multiply straight across. You get 6/5. And then that changes to what? 1 and 1/5. If the fraction is less than 1,
Keep it the same.
notice, if my fraction is less than 1, and I have a whole number, what is happening to my answer?
Getting smaller.
The whole number decreases. So if I am multiplying a whole number times a fraction that's less than 1 whole, it makes that whole number smaller. Okay, typically when I multiply, numbers get bigger, but when I'm multiplying by a number less than 1, still greater than 0, but it's less than 1, it just shrinks that whole number down. Now, if the fraction is greater than 1, what's going to happen to the whole number? It'll increase. So that's like a mixed number. We're going to be working with mixed numbers later this week. Okay, any questions on that? Okay, last one for today. I wanted to do one like this because this is what you're going to see on your practice today. So it says, find the product by shading in the parts. Now this is a little different because I don't have 6 models where I'll shade in 2/5 on each of the 6 models. So I'm going to show you this one because this is what you're going to have in just a minute. I want you to have a completed example of what that looks like. Now if I have to shade 2/5 6 different times, Eli, what do you think I can do?
You can like shade more than 1/2 and more than 1 bar.
Yeah, so I have, this is 1 2/5. Here's another 2/5. So how many 2/5 do I have now?
2.
I have 2. I can take this one plus this one, and that's how many fifths?
3.
That's another 2/5. So I have 3 groups of 2/5. How many more do I need?
6 or 3.
I need 3 more. This is 4 groups of 2/5. Here's another group of 2/5.
You could just do 3 in each box.
And then here's another group of 2/5. So I can see now that I have 1 whole plus another 1 whole plus 2/5. So 1 plus 1 is how much? And then I have 2/5 left over.
Could you not just do 3 at the
Yeah, you can. I just like to show that these make up a whole. Like I have a hole here and a hole here. Okay, now on the standard algorithm side, this one's fairly simple. What do I need to put in this box underneath the 6? A 1. And then I just multiply straight across. 6 times 2 is 12. 1 times 5 is 5. This has to get changed to a mixed number.
2.
So 5 goes into 12. How many whole times? 2. And I would have 2/5 left over. Okay. Now when I'm looking at all of this, I need to answer these questions at the bottom because I think you have one just like this. So how many holes and parts are shaded? I have 2 holes and 2/5 parts. And then what is the product over here? My final product, I just fixed it here, is 2 and 2/5. Okay, that's it. Your practice today is this. I don't think it'll take you the whole time, so you can work on one of the game kit practices in Google Classroom. If you need to go back and work on one of the quizzes that we did last week that counted as a quiz grade, if you were unsatisfied with your grade, you can redo that as well.